In this question, you have to identify the condition when asymptote in a logistic growth curve is obtained. Now, asymptote is a mathematical term, which means a curve is a line such that the distance between the curve and the line approaches zero as the x coordinates tend to infinity. Now, a population growing in a habitat with limited resources shows a logistic growth curve. And for logistic growth curve, dn by dt is equal to Rn into k minus n by k. Now, if k equal to n, then k minus n by k would be 0. Then dn by dt obviously would be 0. And the population then reaches asymptote. Now, coming to the options, option A, k equal to n. Now, in a logistic growth curve, we have already seen that the asymptote is reached when the population size, that is n, equals the carrying capacity, that is k. And at this point, the population growth becomes 0 because the environment can no longer support additional individuals, leading to stabilization of the population. Hence, it is the correct option. Option B, when k is greater than n. This is incorrect because in this condition, the population is still growing because there are enough resources to support an increase. So the growth curve has not yet reached the asymptote. Option C, when k is less than n. It is also incorrect because in this condition, the population exceeds the carrying capacity, and this leads to negative growth as the population decreases due to resource limitations or other factors. So this is not the point where an asymptote is observed. Option D, the value of R approaches 0. Now, small r denotes the intrinsic growth rate. Now, while R does slow down as the population approaches k, but this is not the consequence of reaching k. And it is not the defining condition for reaching the asymptote. The asymptote, as already mentioned, is specifically defined when k is equal to n. Hence, this is also incorrect.